Question 26. OAYB is a quadrilateral. The diagram is not accurately drawn. But from O to A, the vector is 3A. From O to B, the vector is 6B. Part A. Express A to B in terms of A and B. So if I want to travel from A to B, but I can only use this left direction and the B direction, which is going almost straight up, if I followed 6B, I'd end up in the middle of nowhere. 3A takes me further away from where I want to go. But we can backtrack along this 3A vector. So by going a vector of negative 3A, I'm going to end up back at point 0. So at point O, I can now follow this 6B vector to take me straight up to B. So my vector from A to B is 6B take away 3A. You could have also done that the opposite way around, negative 3A add 6B. Point X is a point on AB such that AX to AXB is given by the ratio of 1 to 2. And the ratio from B to Y is given as the ratio of 5A take away B. Prove that O to X is written as is the same as 2/5 of the vector from O to Y. Okay, so this is going to be the big finale for this paper. It's a 4-mark question. Firstly, we need to know what the vector from O to X actually is. So if we look at our diagram here, to get from O to X, we can go from O to A, and then part of the way up our vector from our first answer. So if the ratio is 1 to 2, that tells us that AX is exactly 1/3 of AB, and the remaining bit would be the final 2/3. That would give us our ratio of 1 to 2. So firstly, our vector from A to X is equal to 1/3 of our vector from A to B. And in this case, that would equal 1/3 of 6, which is 2B, and 1/3 of 3A, which is A. So we've got 2B subtract A. So if we want to find out what the vector from O to X is, so we have O to X, what we're also going to have is the instructions to go from O to A first. So go from O to A and then up to X. So we're going to add on 3A. So we have 2B minus A add 3A. And that gives us a vector from O to X of 2B add 2A. So what is the vector then of O to Y? Well, we're given this vector from B to Y, so to get there we're going to have to go from O to B first and then back down along this line. So we take our vector of 6B to get up to point B, and then we're going to add on the vector from B to Y, which is 5A minus B. Simplify this vector. We've got 5B take away B, means we've got, 6B take away B is 5B, add 5A. So, to prove that they have this relationship, let's find out what 2/5 of the vector from O to Y is. So we're going to find 2/5 of the vector 5B plus 5A. Well, 2/5 of 5 is 2, so that's 2B. 2/5 of 5A is 2A. And that shows that these are identical vectors.